Kia ora Year 12 and 13. This is today's revision question for A-level. This is a stats question, or actually it's two questions. Now the first one, question 3, is also quite good for practice for level 3 stats because it's looking at combinations of random variables. So it's a normal distribution problem. It's pretty straightforward, but it's a good example of having to be careful with whether I'm dealing with a linear combination or the sum of independent random variables. The second one is kind of a classic probability thing where you're given a PDF and you have to do the usual things with it. So let's start off on question 3. We're told that we've got sugar and flour for making cakes and it's measured in cups. And the mass of 1 cup of sugar has got this distribution. So it's normal with a mean of 250, and just note that that 10 is the variance, right? It's not the standard deviation. That's the convention that the A-level papers all use. Okay, so sigma squared is 10. And the mass in grams of 1 cup of flour has the independent distribution of this. And each cake contains 2 cups of sugar and 5 cups of flour. It's pretty straightforward. We just have to find the probability that the total mass of sugar and flour in one cake exceeds 1310 grams. So what I have to do is to set up a new random variable, and I'm going to call that T, the total. So the important thing is not to make T 2x plus 5y, but instead to think of it as 1 cup of sugar plus a second cup of sugar plus the first cup of flour, the second cup of flour, and so on. And we've discussed this in class, but if you do it this way, you'll get your expected value correct and you'll get your variance correct, because the variance is just going to be the sum of all the separate variances, right? The mistake that students often do is that they think that they're finding this, e of ax plus by, and var of ax plus by. And so the mistake made is in here, because this is going to have a variance of a squared var x plus b squared var y. But that's not the situation we've got. We've got 7 separate things with variation being put together, and so our variance is going to be the sum of those variances. So the expected value of the total will be 250 for this one, and then 160 for this one, and this one. So that gives me 2 times 250 plus 5 times 160. Right, and that's going back to these basic distributions here. And the variance of T will be the variance of x1 plus the variance of x2, and so on. So that's 2 lots of 10 plus 5 lots of 9, which gives us a variance of 65. And the average, that E of T, is 1,300. So what we're asked to find is the probability that the total mass of sugar and flour exceeds 1310 grams. So this is my distribution of T. This is 1300. We want to find this probability here. Right, so what I need to do is to standardize. I've got the probability that T is greater than 1310. That's the probability that Z is greater than this. So subtract the mean and divide by the standard deviation, which is root 65. That gives me a Z value of 1.240. So we can draw that. Well, we've drawn it already. We've drawn it for T, now we'll draw it for Z. So we want this probability here. I'm just trying to draw that a little bit more accurately given my standard deviation. Okay, so this value here is 1.240. So using my tables, that works out to be 1 minus phi of this. 1 minus 0.8925. Make sure you've got lots of practice in it using the tables as they're given, which is 0.1075. So there you go, that's the first part of this video done. Now we're going to look at the second part. We're given a probability density function, and it's for a lot of runners completing a race. And it's modelled by this. So where there is probability in the model, we use this function, and that's between 0 and a. Otherwise, we say that the probability is 0. So I'm going to do actually part 2 first, which is to state what the constant a represents in this context. So you can see that we're saying that there's no probability of being above that time. So a represents the longest time it takes someone to run this race based on this model. Okay, so that's part 2. I'm not going to write that all out. But it's a is the longest or the maximum time that a runner takes to finish this race. Because if they're not within these bounds, we're saying that there's no probability. So that's one little mark there. But the first thing we have to do is to look at the PDF and show what the value of this constant is in terms of that maximum time. So to do that, we're going to use the fact that probability density functions integrate to give me 1. So we need to solve the following equation. I'm going to rewrite that as follows. So we'll have k times this integral equals 1. So integrating gives me negative x plus 1 to the negative 1 between a and 0. Now I'm not going to leave that k there anymore. I'm going to reverse it over to here. So we'll get 1 over k. So that's gone. And now we're going to substitute an a. So we have 1 over a plus 1 minus 1 over 0 plus 1. Substituting these values in is equal to 1 over k. That gives us 1 over a plus 1 minus 1 is equal to negative 1 over k. Let's show that question. So we need to show each step. So now we've got 1 minus a minus 1 is equal to negative 1 over k. Negative a over a plus 1 is equal to negative 1 over k. Going very slowly here. Okay, so a over a plus 1 is equal to 1 over k. Cross multiplying gives me k is equal to a plus 1 over a. Okay, so that's that question done. Now let's look at the third part. I think that's all we had to show. Yep, so we had to show that this is this. Next, we're told that 3/4 of the runners take half an hour or less to complete the race. So now we've got to finally find the value of a, the maximum running time. So this one, we have to think about how to set it up carefully. What do we know and what do we not know? Well, we now know, whether we got there in the last question or not, that k is equal to this thing here. So we can write down the following statement. The probability of being between half an hour and no minutes is equal to 0.75. So let's start here. Pretend that we haven't worked out what k is first. Right, so that's what we could have said at the very start of the question. And now we know that k is equal to a plus 1 over a. So we're going to solve this equation for a. So you can try this while I'm just cleaning up this bit of the laptop. So pause the video and try and work that through and see what you get. And I'm going to do that now. So k is equal to a plus 1 over a. So that can sit out here. We've got 0.5 to 0. We've already done this. So we have negative 1 plus x to the negative 1 from 1/2 to 0 is equal to, so cross multiplying here, we've got 3/4 times a over a plus 1. So we work this through now, work through the integral. I'm going to pause the video so you don't have to watch me writing it all out. Okay, so there's my substitution part done. I could have taken the negative through to the other side, but I haven't. So we've got negative 1 over 3 over 2 plus 1 is equal to 3a over 4 times a plus 1. that gives me here negative 2/3 plus 1 is equal to 3a over 4 times a plus 1. So we've got 1/3 is equal to 3a over 4 times a plus 1. 4a plus 4 is equal to 9a. 4 is equal to 5a, and a is equal to 4/5, or 0.8. So the most time taken by the runners is, this is in terms of hours, I think. Let's just check. Yep, it's a number of hours. So over here, 0.8 of an hour is 48 minutes. So in the schedule, they just need a equals 0.8, but 0.8 times 60 is 48 minutes. So that's how long it takes the longest runner. So you weren't asked to find it like that, but I think that makes more sense in context. The final answer they need here is just a equals 0.8. Alright, thanks for watching. I'm sorry this one was a bit rough in terms of layout and stuff, but hopefully it gives you the idea of what you really need to practice. Both of these types of questions come up all the time, and they are really, really easy as long as you're very confident with what you've got to integrate and why.